All right, in this lesson we are finding the average rate of change over an interval from a graph, a table, and an equation. Okay, so the key idea here is we're finding the average rate of change over an interval from a graph, a table, and an equation. Average rate of change. And this is at an algebra 2 level of this concept. This concept goes deeper into calculus and beyond. But we're going to look at an algebra 2 level. So, just real quick, when you were talking about lines back in algebra 1, you learned about the average rate of change. You called it the change in y over the change in x. And we defined it as y2 minus y1 all over x2 minus x1. Sometimes, if you wanted to get fancy, they use the symbols delta y over delta x. And delta is the Greek letter. And we use it to represent change. So the change in y over the change in x. Now this, another way of saying it is, it's just it's just the slope. Okay, so when I'm talking about the average rate of change for a line, I'm talking about the slope of the line. Now, special, as it says here, so special circumstance exists. All right, so just reading over this real quick. What phrase do we use to find slope from a graph? Think back to algebra 1. What do we use when we were talking about the slope? Rise over run. You do you. Okay, so here, in this particular line, the rise over the run, that's what we're looking for. Here you can see the rise is 2, and the run is 1. If we look at a different section of the line, from this point, the rise is 2, and the run is 1. Okay, the slope is constant. That's a big concept for a line, because there's no other function that has the same fact about it. The slope, the average rate of change, if you look at the slope for any other shape, it's not going to be constant. It's only constant for a line. It's a big deal. I'm saying it's a big deal. I'm not just making this up. It's a major concept. All right, so nonlinear functions. Let's talk about something that's not a line. When you're working with nonlinear functions, the average rate of change is not constant. It's not going to be the same. You will be given an interval to find the slope. So it's not just you can do an interval here or an interval there like we did on the line, but I'll have to give you a very specific interval. For instance, if we want to find the rate of change from, this is x equals 0 to x equals 1, that's the question. Find the average rate of change here. Well, this is the change in y over the change in x. So the change in x is going from 1 to 0, so it's 1 minus 0. You can write that in. This is part of your notes. Now, what is the y value when x is 1 on this parabola? What's the y value? What's the y value when x is equal to 1? On this graph. Yes? Pass. What's the y value when x is 1? I'm waiting. It's 1, right? X is 1 here, the y is 1 minus. Okay, what's the y value when x is 0? 0. Okay, so this comes out to be 1 over 1. So, what's the average rate of change from 0 to 1? From 0 to 1? It's 1. Box that in. That's the average rate of change. Okay? Now let's find the average rate of change from x equals 1 to x equals 2. Okay, so the change in y over the change in x, in this case. Another way of writing it would be f of 2 minus f of 1 all over 2 minus 1. What is the y value when x is 2? When x is 2, come up to 4. Alright, so the y value is 4 minus, so f of 2 is 4, and what's f of 1 equal to? What's the y value when x is 1? 1. It's 1. So on the bottom you have 2 minus 1. And what is 4 minus 1? It's 3. And what's 2 minus 1? It's 1. So what's 3 over 1 equal to? It's 3. Alright? Let's find the rate of change between 0 and 2. Change of y over the change of x from f of 2 minus f of 0 all over 2 minus 0. And what is f of 2 going to be equal to? What's the y value when x is 2? It's 4. What's the y value when x is 1? 0. And 2 minus 0. So 4 minus 0 is 4. 2 minus 0 is 2. 4 divided by 2 is 2. Okay, so notice down here it says you will learn in later courses that the average rate of change in nonlinear functions is actually the slope of the secant line passing through the two chosen points. The secant line cuts a graph in 2 points. Alright, so here's what I'm trying to highlight to you right now. When you're looking for the average rate of change in a nonlinear function, it depends upon the interval that you're talking about. For instance, the interval from 0 to 1 gives us a slope of 1. The interval from 1 to 2 gives us a slope of 3. And the interval from 0 to 2 gives us a slope of 2. Yeah, so I think that would be a good point for us to kind of stop this lesson. We'll continue it in the next video. So thank you for watching.